Hello, my name is David Surplus. I'm the Managing Director of B9 Energy Storage Limited from Larne in County Antrim. We've developed wind farms here in Northern Ireland 30 years ago. We built 10 projects altogether, and including development of an offshore wind farm at 600 megawatts. And that was an enormous project for the size of the population of Northern Ireland. And we discovered that itself would be leading to wind farms having to be switched off. So at that point, we decided we'd look at energy storage to find a way of balancing the wind farms. And we assessed all the different technologies available, but ended with electrolysis as being the single best way of providing the balancing load. That genre is called Power-to-X. And so today I'm going to give you a presentation about where we're at with that technology. Power-to-X is where you take electricity, you electrolyze water to produce hydrogen, oxygen, heat, grid services. And the X piece is what you then do with that offtake. So in this case today, we'll be talking about power-to-gas. And one of our main partners in this is Phoenix Natural Gas, which was the original distribution network operator in Northern Ireland. We're working on a couple of projects with them, and I'd like to thank them for sponsoring my presentation today. So we've been the victims of our own success. The wind industry in Northern Ireland has been fantastic. We are over half the amount of energy we produce now, electricity-wise, is from renewables. And we have the highest instantaneous penetration of wind farms on any grid in the world at 70%. So that's world-beating, and we're very proud of that as a community. But what this has resulted in is dispatching down of the wind farms. So the wind farms have to be switched off when there's too much wind generation and not enough instantaneous load. For 2020, that number ended up being 14.8%. So in other words, 14.8% of the energy we could have generated. The wind turbines were there, the wind was there, but there just wasn't any off-takers. This equates immediately to 14.8% loss in revenue for wind farmers, which is the difference between profit and loss, which means that investor confidence in new wind farms has dropped and is still low, and it will remain low until we can bring these dispatchable loads into place. So just having a quick look at the load that exists today, this curve shows all of the days in the year. The red curve is the minimum load in each day, and the blue curve is the maximum load in each day. The red dot is the installed capacity of wind farms in Northern Ireland in 2020. And what the government now wants to do, as far as its decarbonisation agenda is concerned, is to add 1,600 megawatts to that installed capacity. So by 2030, we need that red dot worth of generation. So we have to provide the balancing load. Well, we've got the 600 megawatts minimum that's there all year round. We've got 500 megawatts that could be exported to Scotland through the Moyle interconnector, although at the moment you're only able to export 250. There's the new north-south interconnector that would allow 900 to be exported into the Republic. And that leaves over a gigawatt of Power-to-X projects that could then make up the difference so that the system operator uses this as a tool to bring about the balancing. This is by 2030. There would have to be some fossil stations there for inertia, so about 150 megawatts. Now, if it's windy in Northern Ireland, it's likely to be windy in Scotland and the Republic of Ireland, our neighbouring regions. And that would mean that some of these interconnectors, they wouldn't be able to be exported through because they would have enough of their own. If we look at the installed capacity of electrolyzers that would bring about a 20% penetration of hydrogen into the network in Belfast that's operated by Phoenix, then you can see there it's quite a small amount in proportion to the total. So what is Power-to-X? We've got our nighttime wind from otherwise curtailed wind farms. During the day, there isn't much curtailment, so we would have a captive solar farm that maybe otherwise couldn't get a cost-effective grid connection. The electrolyzer is carrying out the process of electrolysis. It will split the water into hydrogen and oxygen. It's called a high-pressure electrolyzer because it does all of this at 34 bar pressure, which means you don't have to compress the hydrogen immediately. You put water in, and you control the machine as a demand-side unit, which is a term used in the electricity regulations. And this is grid services, so you can get a revenue stream for helping the grid to perform correctly. Hydrogen would be produced, put into a dedicated pipeline where you would have 100% hydrogen customers taking the product immediately from that pipeline. But also you would put the gas in through a mixing entry skid and put a blend then into the existing natural gas networks. A 20% by volume in the natural gas is a point at which the distribution networks don't have to be amended, and neither does anybody have to change any of the appliances which they currently use. So that's the sort of easy threshold to be aiming for in the first instance. We also get oxygen. In the case of Northern Ireland, we're looking at using the oxygen in the wastewater treatment plants to accelerate the aerobic reactions that mean we can create some capacity in already constrained wastewater treatment plants. And then finally, there's some district heating applications which can be supported with about 30% of the electrical input being used as heat. So we mentioned there the Phoenix Natural Gas as the original distribution network operator in Northern Ireland back in 1998. And all of our pipelines in Northern Ireland in the distribution systems are made of polyethylene pipe, so they're plastic. And that means that they're immediately compatible with hydrogen. And that makes us ahead of the game, certainly by comparison with GB. So we've installed the world's first membrane-free electrolyzer in Belfast here to do oxygenation trials. And the success of those trials has allowed us to progress to a 1 megawatt demonstration project. And you can see here that a 1 megawatt electrolyzer will fit into a 40-foot container. We don't have membranes that are there normally to separate the hydrogen and the oxygen by virtue of the difference in the size of the molecules. We use, in this project, cryogenic separation, so the mixture of gases is chilled down to minus 200 degrees C, and at that point the oxygen liquefies, but the hydrogen remains as a gas. So separation is just separating a liquid from a gas, which is very straightforward to do. It gives us some unique selling points for these devices. They have a 25-year life because the membranes fail and need to be replaced throughout the life. No membrane-related failure modes. It therefore gives a lower cost of ownership than PEM and alkalines, which are the rival technologies. There's no platinum group materials to worry about for cost and the rarity of them. And we can also chill the hydrogen down a bit further, and it in turn would also liquefy, which means that we have cost-effective production of liquid hydrogen on a small distributed scale, which is not available from any other technology. The future of hydrogen will all be liquid because it's a higher density storage in the future. The stacks, those little biscuit tin things there, they're very small and they can be mass produced. And as a result, you can manufacture these machines 20 times faster than a PEM electrolyzer, which means when we really have to scale up, then a factory would be able to make these things much faster. And indeed, B9 has now entered into a joint venture company with CPH2 from Doncaster. The company's called CPH2NI, and we're going to, all being well, create up to 1,000 jobs in an assembly plant in Northern Ireland. And from a developer's point of view, what that gives us is control over the product availability, because you have to wait 2 years to get an electrolyzer at the moment. We would have them whenever we need them, and we'd have some control as well over the price point. So I think that's all I had for you today. Thank you very much indeed. Thank you.